I'm putting one of the most circulated ideas about Bigfoot to the test. A statistical significance test, that is. Are the reported heights of Sasquatches in the western United States actually larger than those reported in the south? Now, I have personally never seen data that either confirms or denies this idea that's often perpetuated throughout the Bigfoot community. So today, I am here to challenge this idea and see if it holds true when we look at the data and run statistical significance testing on the data. Also, before fully diving in, hi, my name's Terrestrial. I created the Sasquatch Data Project and am making the first open source dataset that's optimized for data analysis for Bigfoot researchers. Every investigation I do uses this dataset that's been created from BFRO reports, where basically I'm taking all of the useful bits and putting it into this massive, glorious spreadsheet. So if Bigfoot and data are your jam, make sure to give this video a big ol' thumbs up, subscribe to my channel, and while you're at it, follow me on Instagram and TikTok too. Now, I'm not really sure how this rhetoric got started that there's smaller Sasquatches in the South over the western United States. I think potentially this is partly due to this idea that Sasquatches follow Bergmann's rule. Now, Bergmann's rule basically says that animals of the same species that live in cooler climates are often larger than those that live in warmer climates. And most of the western states, especially those that we will be looking at today in this investigation, are generally cooler than the southern states that are included. So potentially this is where that idea stems from. Or maybe it's just hearsay that's been spread throughout the community for decades. I do not know. While I can't exactly pinpoint where this idea got started, we can just go ahead and start this analysis and see if it even holds true with how the data currently stands. At the time of filming this video, I have parsed 1,334 reports off of the BFR website. These 1,334 reports are from 25 different states. And it's important to know that I am not done parsing reports. This investigation is going to be a preliminary analysis of the data. The states that are included in the southern region are Alabama, Arkansas, and Delaware, Georgia, Mississippi, and North Carolina, Oklahoma, South Carolina, and West Virginia. The western states are Alaska, Colorado, and Utah, Idaho, Montana, and Nevada, Oregon, and Wyoming. And to further strengthen this analysis, I am only looking at Class A sightings of Sasquatches. Now, if you're not familiar with what Class A means, basically the witness, without a doubt, saw an ape of unclassified species in North America, aka a Sasquatch. One last little thing I need to address before we totally dive in, and before anyone comes for me, is that we are dealing with presence-only data. Now, this basically means we only have data from when a human saw a Sasquatch and then took the time to report it. We do not have data from the Sasquatches that were never seen but are indeed roaming about. And we also don't have data from the people who've never reported their sighting. The TLDR, though, is that we acknowledge this potential source for error, and also we will be extra cautious when interpreting our significance test results. So with all these considerations and stipulations, our total sample size for this analysis is 504 data points. The West has 213, and the South has 291 individual heights reported. Okay, now that we have a really good idea of what our data is, what it looks like, why we're using that particular subset of data, it's time to dive into the statistical significance testing. But why in the world do we even care about significance testing, and what can it tell us about the data? Statistical significance testing allows us as Bigfoot researchers to put power and meaning behind our words. It can help turn our opinions and ideas that we might have about Sasquatches into something with some substance that's backed by math. This is really rad and exciting, and something we should strive for if we want to continue our scientific investigations into Bigfoot. Statistical testing in itself basically tells us how likely these patterns that we're seeing in the data are due to random chance. So for example, in our study today, if we find that there is statistical significance between the reported heights from the South and the West, and those heights are typically larger than those reported in the South, we can feel pretty confident that there is some other factor at play here influencing these heights. And that it's not just random chance that we're seeing this pattern in the data. And those factors that could be contributing to this pattern could be environmental, physical, genetic, or something else entirely. On the flip side, if we find no statistical significance, then that means that the data's saying there's not a very big difference between the heights that are reported from the western United States and the southern United States. So let's learn a little bit about the statistical significance test that I'm going to be using today. I did use a couple in this investigation, but the first one was the Mann-Whitney U-test. And without getting too in the weeds of what this test is or why we're using it, basically, we're interested in learning about the distributions of the heights themselves between the South and the West. It basically tells us how similar or different the two groups of data are as a whole. So to break it down this way, it's kind of like if you wanted to compare the shapes of an orange and an egg. They're similar in that they're both round, but there are definite differences there. So we want to see if there is a statistically significant difference in the shapes of an orange and an egg. But in our case, it's the heights of Sasquatches. And now I want a snack. So after running this test on the Bigfoot data, not the orange and the egg, I did not find statistical significance between the South and the West. And for all you math nerds out there, the U statistic came back as 30,460, which is very close to our expected value of 30,991.5. And basically the expected value is what the U statistic would be if there were zero differences between the two groups. They were exactly the same. And the p-value, which basically tells us how likely the observed patterns are due to random chance, came back as 0.7398. And if there was statistical significance, we would expect a p-value under 0.05. So we're way off from that threshold. So it ain't looking good for statistical significance. Now, if that test isn't enough for you, I did run two more. The Kolmogorov-Smirnov test, or the KS test for short, and a permutation test. Now, the KS test also looks at the distribution of the data rather than the median or the mean, while the permutation test looks at the differences between the means. Starting with the KS test, I calculated a KS statistic of 0.0799, and I got a p-value of 0.3868. With a p-value that large and a KS statistic that small, this is still indicating no statistical significance. The permutation test revealed that there's only a negative 0.0494 difference in the means, and the p-value was 0.6664. This in itself indicates that the means from the two groups are extremely similar, and also points to the South having slightly larger heights reported over the West, which was a little unexpected. And we know this is the case because of that little negative sign. And a very quick calculation confirms this. The South's average reported height is 7.28 feet, while the West's is 7.22. And the permutation test reveals that this difference in heights is not statistically significant. It's actually extremely small, and basically the difference is negligible. And to just take this one step further, I did one more calculation, which is the effect size. Now, the effect size just helps us interpret how meaningful this difference is that we're seeing between the southern and western reported heights. And to do this, I calculated something called Cohen's d, which came back as negative 0.0401. And this is a super small Cohen's d, and I know there's a joke in there somewhere, but we're just gonna move on. So if we combine the results of all of these tests that I've run today on the current data, I feel pretty confident in saying that as things stand right now, the Sasquatches that are reported from the western United States are not really taller than those that are reported in the South. But it's important to note that this could absolutely change as more reports are added to the Sasquatch Data Project Dataset. Also, I want to make it clear that I'm not saying this is necessarily due to a biological reason. There are many different factors that could be contributing to these results. Potentially, one of these factors could be part of this preconceived notion of how tall a Sasquatch should be. A common height range that I hear from believers and skeptics alike is that Sasquatches are 7 to 8 feet tall. Recently, I did a poll on Instagram asking my followers how tall they thought Sasquatches were, and out of the people who responded to that poll, 72% said 7 to 8 feet tall. So it could be when witnesses are having this experience, seeing a Sasquatch, they're leaning on this subconscious thought process that Sasquatches are 7 to 8 feet tall, when in reality, the animal they're seeing is smaller or larger. Potentially, another thing that could be happening is fear-driven magnification. This is a documented psychological phenomenon that basically says when you're super freaked out, you perceive the threat as much larger than what it actually is. And in so many of these reports, and I'm working on an exact number, just bear with me, the witnesses are very detailed in how freaked out and scared they are during and after the encounter. For so many of these witnesses, this encounter is literally life-altering for them. So if someone is under that much stress and fear, they're likely to perceive the Sasquatch as larger than it potentially actually is. So if the Sasquatch is 6 feet tall, it may be perceived as 7 or even 8 by the witness because of this fear-driven magnification. Also, it is common knowledge that people are notoriously bad at estimating sizes and distances. And I've had people say that this type of investigation that I'm doing with the Sasquatch Data Project is totally useless because of that, which I disagree wholeheartedly with for a number of reasons, but that's for a different video. But to save us from our inability to estimate accurately, there is this thing called the wisdom of the crowd. Basically, if you ask a large enough group of people to estimate the size of something, people are so bad at under and overestimating the size of that thing that when they do these extremes on both sides, it basically cancels each other out, and the average that you get is surprisingly close to the actual value. And this pretty much only works if you have a large enough sample size, which we actually have. Typically, you want about 30 to 50 people to partake in this. But the more data, the better, so really anything over 100 is great. And in our case, we had 504 individual data points, so that is well over this 100 data point threshold. But there are limitations to this phenomenon, and it kind of circles back to that preconceived notion of how big a Sasquatch should be. So that definitely will influence results when you're looking at the wisdom of the crowd. Ultimately, I need to parse more results so we can have a better idea of why there's not really a difference between the heights that are being reported from the south and the west. And as more data points are added to the data set, it might start to shift things a bit. We'll just have to see. But as things stand right now, and contrary to popular belief, the reported heights of Sasquatches from the south actually aren't that much smaller, and they're actually slightly larger than those reported in the West. But I really hope you enjoyed this exploration into the regional height differences of Sasquatches. Make sure you like this video and subscribe so you can stay up to date with all things Sasquatch statistics. Also follow me on TikTok where I go live once or twice a week, and also follow me on Instagram where I post almost daily. And with that, I hope you have a wonderful rest of your day and keep it groovy.